NEC Section 250.38 permits the connection of the grounding electrode conductor to building steel in a manner as prescribed in the NEC. NEC Section 250.122e permits bonding or connecting the grounding electrode conductor to metal underground water piping. In the absence of metal underground water piping, the NEC permits bonding or connecting the grounding electrode conductor to steel reinforcing bars in concrete footings or foundations, in accordance with NEC Section 250.122e3. NEC Section 250.122e3 requires that the grounding electrode be connected to the nearest accessible reinforcing bar not less than 1/2 inch in diameter, by means of at least one copper or listed copper-clad steel bonding jumper not less than number 6 AWG, with star washers or other suitable means to assure good electrical contact. The NEC permits the grounding electrode conductor to be connected to the building steel provided that it is securely fastened by means of a copper or copper-clad steel bonding jumper not less than number 6 AWG, with star washers or other suitable means to assure good electrical contact. When dealing with grounding electrode conductors and their connections, it's essential to understand the specific requirements outlined in the National Electrical Code or NEC. The NEC provides detailed guidelines to ensure safe and effective grounding practices. Firstly, NEC Section 250.38 addresses the connection of the grounding electrode conductor to building steel. This section explicitly allows for such a connection, but it emphasizes that the connection must be made in a manner that adheres to all other applicable requirements within the NEC. This means that simply connecting the grounding electrode conductor to building steel is not enough. The connection must be done properly and in accordance with the NEC standards. Secondly, NEC Section 250.122e provides further clarification and options for connecting grounding electrode conductors. It permits the bonding or connecting of the grounding electrode conductor to metal underground water piping. This is a common and often preferred method of grounding, as underground water pipes typically provide a reliable connection to the earth. However, it's important to note that this option is contingent on the presence of a metal underground water piping system. In situations where metal underground water piping is not available, the NEC offers an alternative. It allows for the bonding or connecting of the grounding electrode conductor to steel reinforcing bars in concrete footings or foundations. This alternative is detailed in NEC Section 250.122e3. NEC Section 250.122e3 outlines specific requirements for connecting the grounding electrode to steel reinforcing bars. One key requirement is that the grounding electrode must be connected to the nearest accessible reinforcing bar. This reinforcing bar must be at least 1/2 inch in diameter. The connection must be made using at least one copper or listed copper-clad steel bonding jumper. The minimum size of this bonding jumper is number 6 AWG. To ensure a reliable electrical connection, star washers or other suitable means must be used. These ensure good electrical contact between the bonding jumper and the reinforcing bar. Finally, the NEC permits the grounding electrode conductor to be connected directly to the building steel. However, similar to the connection to reinforcing bars, this connection must be securely fastened. A copper or copper-clad steel bonding jumper, no smaller than number 6 AWG, must be used. Again, star washers or other suitable means are required to ensure good electrical contact. In summary, when connecting a grounding electrode conductor, the NEC provides multiple options, each with its own set of requirements. Whether connecting to building steel, metal underground water piping, or steel reinforcing bars, it's crucial to follow the NEC guidelines meticulously to ensure a safe and effective grounding system. These guidelines cover the size and type of bonding jumpers, the methods of connection, and the materials that must be used to ensure a reliable electrical connection. The grounding electrode system serves a critical role in electrical safety, providing a path for fault current to return to the source, tripping over current protective devices, and minimizing the risk of electrical shock. A properly installed and maintained grounding electrode system is essential for the safety of people and equipment. When dealing with electrical installations in Class 1 Division 1 locations, the importance of proper grounding is amplified. Class 1 Division 1 locations are areas where flammable gases, vapors, or liquids are present under normal operating conditions intermittently or frequently. In such hazardous environments, electrical equipment and wiring must be specifically designed and installed to prevent ignition. Grounding plays a vital role in minimizing the risk of sparks or other potential ignition sources. The NEC provides specific requirements for grounding in hazardous locations, including Class 1 Division 1 areas. These requirements are designed to ensure that electrical equipment is properly grounded to prevent the accumulation of static electricity and to provide a low impedance path for fault currents. In Class 1 Division 1 locations, all metal enclosures, raceways, and other non-current carrying metal parts of electrical equipment must be bonded together and connected to a grounding electrode system. This bonding and grounding helps to equalize the potential between different metal parts, reducing the risk of sparks or arcs. The grounding electrode system must be designed to provide a low impedance path to ground, ensuring that fault currents can quickly and safely return to the source, tripping over current protective devices and minimizing the duration of any potential ignition source. The use of appropriate bonding jumpers and connectors is crucial in Class 1 Division 1 locations. These components must be specifically listed and labeled for use in hazardous locations and must be installed in accordance with the manufacturer's instructions. The connections must be mechanically strong and electrically sound to ensure a reliable grounding path. Regular inspection and maintenance of grounding systems are essential in Class 1 Division 1 locations. Ground connections should be inspected for corrosion, looseness, or other signs of deterioration. Any damaged or corroded component should be replaced immediately. The grounding electrode system should also be tested periodically to ensure that it provides a low impedance path to ground. In addition to the general grounding requirements, the NEC also provides specific guidelines for grounding intrinsically safe circuits in Class 1 Division 1 locations. Intrinsically safe circuits are designed to limit the amount of energy available to prevent ignition of flammable materials. However, even intrinsically safe circuits must be properly grounded to ensure their safety and effectiveness. The grounding of intrinsically safe circuits must be done in accordance with the manufacturer's instructions and the requirements of the NEC. Special grounding techniques may be required to minimize the risk of ground loops or other potential hazards. Proper documentation of grounding systems is essential in Class 1 Division 1 locations. Detailed records should be kept of all grounding connections, bonding jumpers, and grounding electrode systems. These records should include the location of each connection, the type of connector used, and the results of any grounding tests. The documentation should be readily available for inspection and maintenance purposes. In conclusion, connecting a grounding electrode conductor to building steel in a Class 1 Division 1 location is permitted by the NEC provided that it is done in accordance with the code's requirements. The NEC provides specific guidelines for grounding in hazardous locations, including Class 1 Division 1 areas, to ensure the safety of people and equipment. These guidelines cover the size and type of bonding jumpers, the methods of connection, and the materials that must be used to ensure a reliable electrical connection. Regular inspection and maintenance of grounding systems are essential in Class 1 Division 1 locations to ensure their continued effectiveness. Always consult the latest edition of the NEC and other applicable standards for the most up-to-date requirements and best practices for grounding in hazardous locations. Understanding and adhering to these requirements is crucial for minimizing the risk of fire or explosion in these potentially dangerous environments. Consider the specific environment and potential hazards when designing and installing grounding systems in Class 1 Division 1 locations. It is important to consult with qualified electrical professionals who have experience in hazardous location installations. They can provide valuable insights and guidance to ensure that the grounding system meets all applicable requirements and provides the necessary level of safety. Also, remember to follow all safety precautions when working with electrical equipment in hazardous locations. This includes wearing appropriate personal protective equipment, such as flame-resistant clothing and safety glasses. Always to energize electrical circuits before working on them and use appropriate lockout/tagout procedures to prevent accidental energization. Furthermore, stay informed about the latest advancements in grounding technology and best practices. Attend training courses and workshops to enhance your knowledge and skills in this critical area of electrical safety. By staying informed and following all applicable requirements, you can help to ensure the safety of people and equipment in Class 1 Division 1 locations. Remember that grounding is not a one-size-fits-all solution. The specific grounding requirements will vary depending on the type of equipment, the location, and the potential hazards. Always consult the NEC and other applicable standards to determine the appropriate grounding methods for each situation. In addition to the NEC, other standards and regulations may also apply to grounding in Class 1 Division 1 locations. These may include standards from organizations such as the Institute of Electrical and Electronics Engineers or IEE, the International Electrotechnical Commission or IEC, and the Occupational Safety and Health Administration or OSHA. It is important to be aware of all applicable standards and regulations and to comply with them fully. Proper grounding is an essential component of electrical safety in all locations, but it is especially critical in hazardous locations such as Class 1 Division 1 areas. By following the NEC requirements and best practices, you can help to minimize the risk of fire, explosion, and electrical shock, creating a safer environment for workers and the public. Remember to prioritize safety in all electrical work and to consult with qualified professionals when needed.